Children, in this particular slide, we are going to see all the major theorems. All the major theorems. So one by one is what I have written. Pythagoras theorem for acute angle triangle, Pythagoras theorem for obtuse angle triangle, and Apollonius principle. We are here only to understand the application. Theorems is what we are not looking at, right? We are just saying how the application is and what is the outcome, right? So by this time you should be very much aware when I say outcome, application, what do I mean by saying that? So Pythagoras theorem. This is Pythagoras theorem. What is this Pythagoras theorem trying to say? We are aware Pythagoras theorem from from 7th standard onwards. In triangle ABC, angle B is 90. So what is it Pythagoras theorem trying to say? Hypotenuse square, AC square, is equals to sum of the squares of the perpendicular side, AB square plus BC square. We are aware. So it's not a big deal. Pythagoras theorem is never a big deal for you people. It's never a big deal, right? What is the necessary condition? It to be right angle. Now children, it is up till now, we all teachers and you people also, we never told you. Why? Because you never came across that kind of scope or syllabus. Now within your syllabus, Pythagoras theorem is applied to obtuse angle also and acute angle also. So what mindset we had in our lower classes? We had only one mindset. What? Pythagoras is applied to right angle triangle. Even our teachers must have said Pythagoras is applicable to right angle. Maybe they did not inform you. Why? Because it was not there in the scope. Teacher is aware, but maybe it was not there in the scope. So he or she must have not passed on to you. Today we are going to see that Pythagoras has an application in acute angle also, obtuse angle also. So how we have by-hearted right from class 7th Pythagoras, likewise we are going to by-heart the application for acute angle, for obtuse angle. So let's see what it is. Pythagoras theorem for acute angled triangle, short form for angled triangle. So children, don't you consider this as of now. For you the triangle is triangle ABC. Don't you consider this AD altitude, please don't consider this. So triangle ABC is a acute angle triangle you have in front of you. Now you can pick up any one of the angle. Now so how will I know in the proof which one to pick up? Everything will be told to you in the question itself. In fact, I am going to make the picture here also very much clear that which angle you should pick up, B or C. Here I am picking up angle B. What type of angle angle B is? Acute angle. Again I said our triangle is triangle ABC. Ignore this part. You have to focus in triangle ABC. AD is only an altitude which we have drawn. That's it. Because altitude of a acute angle triangle is always inside the triangle. So let's start. ABC is ABC is a triangle in which we are supposed to focus on angle B, which is acute angle. Then it says on applying the application of Pythagoras theorem for acute angle is AC square is equals to AB square plus BC square minus 2BC into, dot means into, BD. Now sir, it's a bit difficult to by heart. It was very easy, sir. This is a bit tedious. It's very difficult, I know. So now I'm going to say something which is nowhere in any theory. It's only easy way to remember. Mind you, this is nowhere there in the theory. No, this is only the way in which I ask my students to remember. Okay, so if I pick up angle B, if I pick up acute angle B, this is not there. Who is the side opposite to angle B? ACs. So how I start? Understand. Second thing, who is the side opposite to angle B? Angle C. Now tell me, what is angle B made up of? Angle B is made up of by two arms, AB and BC. Angle B is made up of by two arms, AB and BC. Right? So let's understand the way in which I tell you to by heart. In triangle ABC, angle B is 90. Therefore, by application of Pythagoras theorem for acute angle triangle, AC square. So how to remember? Square of the side opposite to the angle. Square of the side opposite to the angle. So which is the side opposite to the angle? AC. Square of the side opposite to the angle is equal to sum of the squares of those sides from which the angle is made. So angle is made up of AB and BC. So sum of the squares of those two sides from which the angle is made. For acute minus, obtuse plus, because that's the difference. Though I have not come here, but say in this way. For acute minus, obtuse plus, twice base. So twice base is entire, into base to perpendicular distance. Base to perpendicular distance, or distance between base and perpendicular. So that's the reason I had to insert AD perpendicular. So distance between the base angle, into angle to perpendicular. Angle to perpendicular. Angle to perpendicular. I shall say once again. Pick up the angle which you want. So we have picked up angle B. Now Pythagoras theorem for acute angle goes in this way. It is side of a square of what? Opposite to that angle. So square of the side which is opposite to the angle, AC square, is equal to square of the side opposite to the angle. So if I have picked up angle B, AC square, is equal to sum of the squares from which the angle B is made, AB and BC. So AB square plus BC square. For acute minus, for obtuse plus. So minus over here, twice base, so twice BC, into angle to perpendicular distance. Angle is B, to perpendicular is D, BD. Once again, children, right? If you have picked up angle B, then opposite to angle B is AC square. So square of the side opposite to the angle, AC square, is equal to sum of the squares from which the angle is made, AB square, BC square, plus twice base entire. When I say base means entire, into angle to perpendicular distance. Angle to perpendicular distance. Sir, I have a query. What query you have, sir? Sir, what if I take angle C as acute angle? No problem. No problem. Then what is the opposite of it? Which side is opposite to it? Then I shall say AB square is equals to, what is angle C made up of? AC square plus BC square or CB square. Since it's an acute, minus twice base, so base is again CB or BC, into angle to perpendicular CD. As simple as that. As simple as that. Now sir, question arises. In exam, who will tell me which angle to go for? Should I go with B or should I go with C? Because both are acute. So how will I know that I need to go with B or C? Again, the thing which I give you as a technique, tip, logic is working. If in your 2 proof AC square is what they are asking, I have to pick up angle B. If in your 2 proof AB square is what they are asking, I have to pick up angle C. As simple as that. If they are asking you AC square, I have to pick up angle B as an acute angle. If they are asking AB square, I have to pick angle C as an. We are done, children. Right? Same wordings, no change. We move on to, as I stated, for acute it is minus, for obtuse it is plus, otherwise thing goes the same. But with the basic knowledge, what basic knowledge we should go with? 8th standard, 9th standard, that for acute angle triangle, the altitude is always inside. For obtuse angle triangle, altitude is always outside. Just keep this in mind. For obtuse angle triangle, altitude is always outside. Now, in this, we are learning Pythagoras theorem for obtuse angle triangle, and angle B is obtuse angle, more than 90, acute less than 90. So, wordings same. If I pick up angle B, so what is our main triangle? Which is our main triangle? Triangle is ABC. Altitude is outside. So what did sir say? If angle B is an obtuse angle, then square of the side opposite to the angle, who is that? AC, AC square, is equal to sum of the squares from which the angle is made, AB and BC. So AB square plus BC square. Since it is obtuse, so plus, acute minus, obtuse plus, twice base is BC. Base is not BD, mind you. Base is BC because our triangle is ABC. Into distance between angle and perpendicular, BD. Again, the language is same. Right? Only thing is minus plus, acute minus, obtuse plus. If B is an obtuse angle, AC square is equals to AB square plus BC square plus obtuse twice base BC dot means into angle to perpendicular distance. As simple to by heart. Right? Last one, Apollonius principle. For Apollonius principle, there is a necessary condition. As we had necessary condition, it has to be a right angle, it has to be an acute angle, it has to be an. Now this is not Pythagoras, this is altogether a different one, but we have taken all in one slide so that you can understand. Apollonius principle has one demand. What is it? It is applicable only when there is a median. And what's a median? A line joining from the opposite vertex onto the midpoint of the base. What is a median? Line joining from the opposite vertex onto the midpoint of the base. So in triangle ABC, either given to me M is a midpoint. If M is a midpoint, then by default BM is equals to CM. Or in other language, if M is a midpoint, AM is a median. So out of these two, one should be there. Either they should talk that AM is a median, or they should say M is a midpoint. Then you can always ask Apollonius principle to be there in the inside your proof. This is the must criteria, midpoint or median. Then what is the application of Apollonius principle? Apollonius principle says either M is a midpoint of BC or AM is a median. Then by Apollonius principle, sum of the squares, that means I'll directly say, what is it? It says AB square plus AC square. AB square plus AC square. AB square plus AC square is equals to twice square of the median, twice square of the median, twice AM square, plus twice BM square. But sir, BM and CM are same, so I have a modified Apollonius also. Rest of the things remain same. AB square, AC square, twice AM square. Instead of twice BM square, I can say twice CM square. Rest of the things are same. Sir, what makes you say that? Because BM is equals to CM. Why? M is a midpoint. So what is Apollonius principle? In triangle ABC, if M is a midpoint of BC or AM is a median, AB square plus AC square is twice AM square plus twice either BM square or twice CM square. Right people? 4 major theorems. Pythagoras, for acute, for obtuse, Apollonius principle. Kindly go through. Be very well versed with it before going for any kind of two proof or numerical sums.